Okay, so the question reads, they're saying a substance in storage tablets contains only carbon, hydrogen, oxygen, okay, and has a molar mass of 300.42 grams per mole. And then they are saying when a 1.2 gram sample is studied by combustion analysis, 3.516 gram of carbon dioxide and 1.007 gram of water are collected. So the question now is, what is the molecular formula of the substance in the tablets? Okay, so we notice that this question here involves combustion analysis, and we've been given the masses of what? Carbon dioxide and the mass of water. So for us to find the empirical formula, okay, and eventually the molecular formula of this compound, we need to know the mass of the carbon and the mass of what? Hydrogen and the mass of oxygen. So we know how we can get the mass of carbon and how we can get the mass of what? Hydrogen there. Okay, so we're going to say carbon dioxide has the mass of 3.516 grams, and then water has the mass of what? 1.007 gram. Okay, so from this mass of water we can get the mass of hydrogen, and then from this mass of carbon dioxide we can get the mass of what? Carbon. We can get the mass of carbon. Okay, so how do we get the mass of carbon? Remember the percentages. Okay, we said any mass of carbon dioxide contains 27.3% carbon, and any mass of water contains 11.2, okay, percent of the what? Hydrogen. So we're going to say mass of carbon is equals to, okay, 27.3 divided by 100, and then we are multiplying by the mass of carbon dioxide, which is 3.516. Okay, so you punch this onto your calculator, should be able to give you 0.9599. Okay, so this here will be the mass of what? Carbon in the carbon dioxide that we've been given. Okay, and then what about the mass of the hydrogen? So the mass of the hydrogen, we use 11.2%, so it will be 11.2 divided by 100, and then we are going to multiply by the mass of water. So the mass of water is 1.007, like that. Okay, so let's punch this onto our calculators. What are we getting? Okay, so according to my calculator, I'm getting 0.11 and then 29 grams. Okay, so this here is the mass of hydrogen in water, then this here is the mass of carbon in what? Carbon dioxide. Okay, and then how can we find the mass of oxygen? Okay, so remember we just use this total here. We just use the total here. So this whole substance here, its total is 1.2 grams. Okay, so in this 1.2 we have this much of the carbon and this mass of the hydrogen. So to find the mass of this oxygen, we are going to say mass of the oxygen, okay, mass of the oxygen is just equals to 1.2, which is the total mass of that compound, minus, okay, 0.9599 minus 0.1129. Okay, so what do we get here? So let's punch this value into the calculator. Okay, so when I subtract this, I'm getting approximately 0.1273 grams. Okay, so I'm getting this as my mass of what? Oxygen. So now from the combustion analysis, we have been able to find the mass of carbon, mass of hydrogen, and mass of oxygen. So now we just follow those simple steps in order to find the what? The empirical formula. Okay, so let's write it here and then find the masses. Okay, so how do we find the empirical formula? always the same. The steps are always the same. So we write element. Okay, so you put the elements in the order that they are. So we have carbon, hydrogen, and then we have what? Oxygen. Okay, and then just under them you put their masses. So we are going to say mass. So the mass of carbon is 0.9599. The mass of hydrogen is 0.1129. Then the mass of oxygen is 0.1273. Okay, so if you have any questions, guys, please feel free to ask. Then we go to what? We go to the moles. So these moles, how are we going to find them? Okay, we're just dividing each mass by the molar mass of that element. Okay, so it will be 0.9599 divided by the molar mass of carbon, which is 12.01. Okay, 0.1129 divided by the molar mass of hydrogen, which is 1.01. 0.1273 divided by, okay, the molar mass of oxygen, which is just what? 16 there. Okay, so what do we get there? Okay, what we are going to get here will be the moles. So these moles will be, so we just divide this value here into the calculator. Okay, so let's punch. So when I punch that value, okay, when I punch that value, I'm getting 0.07, okay, 0.0799 and then 2. Okay, what about here? So if I punch this into my calculator, I'm getting 0.11, another one, and then 67. Then what about this guy here? So here I'm getting 0.0079 and then 4. Okay, so these are the moles that I'm getting. Okay, so from these moles we are going to find the what? The ratios. So how do you find the ratios? Remember, we just divide all these moles by the smallest number of these three moles here. So the smallest number is this. So we are going to divide all of them by that number. So we're going to say 0.007964. Even this one 0.007964. Even this one the same. Okay, 4. Okay, so whatever we're going to find here will be our what? Our ratios in the empirical formula. Okay, so when you divide this, what are we going to get? Okay, so punch on your calculators. Okay, so the first one I'm getting 10.03 and then 5. Okay, the second one I'm getting 14.021. And then the last one I'm just getting 1. Okay, so these numbers here, we notice that we can round them off because immediate after the decimal place here we have a 2. We have a 0 here which is less than 2. Even here we have a 0 which is less than 2. So I can round off this number to what? 10. I can round off this number to 14. And I can also round off this number to just the same one like that. So these numbers here, 10, 14, and 1, will be my ratios in the what? Empirical formula. Okay, so let's write the empirical formula somewhere here. So we can erase this. So the ratios are 10, 14, and 1. Okay, so we are going to say, okay, yes, what is your question? Ask your question. What is your question?
On the part where we dividing, on the part where we're dividing under hydrogen, divided 0.1129 or dividing 1.01. But
Yes.
when I punched on my calculator, it was giving to 0.11178.
It was giving you what?
Can still be correct if I use
0. What?
0.11178.
Yeah, it is still correct.
Still okay.
Yeah, it's still okay.
Then I also had a
Mm-hmm.
For example, the way it was iPhone, is the way our modes were giving 0.07992. Then
Mm-hmm.
we had to divide it by, I mean, it had, let's say, a 5 or a 678. If the Can the two change to 3, or we just still leave it as 2?
You can round it off to 3. Yes.
Okay, thank you.
All right. You're welcome. So it means now here our empirical formula, we are going to say empirical formula. Okay. Our empirical formula will be C10, and then remember the H had 14, and then the O had 1, so we don't write anything. So this one here is our empirical formula. Okay, but the question here is asking for the molecular formula. So how are we going to find the molecular formula? Remember, we just need a factor to multiply this empirical formula with. So the factor will be the molar mass of the molecular uh, formula, which is always given in the question. So this one here. So we're going to divide 300.42, okay, by the molar mass of this empirical formula here. So what is the molar mass of this one here? So we just multiply 10 multiplied by 12.01 plus 14 multiplied by 1.01 plus 16. Okay, so punch this onto your calculator to get the empirical formula molar mass. Okay, so I'm getting 150.23. Okay, so you divide this. So when I divide this, I'm getting 1.999973. Okay, the number continues to go, but you can end there. So we can round this off to 2. So it means our factor is 2. Okay, so meaning that our molecular formula will just be equals to the empirical formula, okay, multiplied by this factor, which is 2 there. So it means our molecular formula will just be C20, H28, and then O2 there, I mean. Okay, so that one there is our molecular formula. Okay, this one here is our molecular formula. So any questions there? Okay, no questions. All right, so that these questions, guys, on finding the empirical formula, the molecular formula, you should never fail those questions. Okay, those are free marks. So I've taught you the simple ones, the ones we did last time, and then these are the ones that involve combustion analysis. Okay, they are thought to be the hard ones that I've told you how to deal with them. Okay, how to find the mass of the carbon, how to find the mass of the hydrogen, and then you just proceed with the same simple steps for finding what? Empirical and molecular formula. Okay, so that's it for this question, and then um, I'll give you an assignment here. Okay, so this is the assignment here. So try out to solve these two questions here that I've put for you. Okay, so you can screenshot it. I think I'll send a picture of this in the group. So make sure you try them. Okay, so a hint on number 1, we notice that the masses there have been given in milligrams. Okay, so I taught you how to change from milligrams to grams. Okay, so before you do anything on this question, make sure that you convert those milligrams to grams, and then you can follow the same procedure that we were doing. All right, so that's all for this lesson.